My name is Aniket Kumar Shah, registration number AP2411001199. So today our group is doing a project on comparison of recursive and non-recursive algorithm in C. Next slide. So our objective is to understand recursion and iteration in C. So we will implement it using factorial and Fibonacci with iterative loops and recursive function in C. And we also measure the execution time using the clock function, which is of file time.h. And we'll also analyze time complexity and space complexity. Next slide. So let's compare recursion and iteration in the simplest form and practical way. Recursion is when a function calls itself to solve a smaller version of the same problem. It always needs two things: base case, that is the stopping point; a recursive case, the smaller subproblem it calls itself with. So for example, here we can see calculating factorial using recursion means the value depends on repeated values, function calls. That is fn, which is equals to n into n minus 1, that is function of n minus 1, until it hits the base case. The base case here is n is equals to 0. And in iteration, on the other hand, uses loops like for, while, and do while. Repeat a block of code. It does not depend on function calls. It just updates the variable inside a loop until the condition fails. The factorial example in iteration uses a simple loop to multiply numbers from 1 to n. Iteration is usually faster, uses less memory, and avoids overhead. That's why compiler and real-world system tends to prefer iteration for performance critical tasks. Thank you.
Hello everyone, myself Aman Madhesiya, registration number AP241100111314. On this slide, I am explaining the factorial algorithm in C using both recursive and iterative approach. First, factorial means multiplying a number by all the numbers before it. Mathematically, n factorial is equal to n into n minus 1 into n minus 2 till 1. In the recursive method, the function calls itself repeatedly. If n is 0 or 1, it will return 1. Otherwise, it will return n factorial into factorial n minus 1. This method is simple and elegant, but it uses more memory due to repeated function calls. In the iterative method, we use a loop. We start with result is equal to 1, and then we multiply result by each number from 2 up to n. This approach is more effective in terms of memory, as it avoids recursive stacked uses. So this slide shows how the same logic calculating factorial can be implemented using two different styles of programming in C. Next slide. Now coming to the Fibonacci series, where each term is the sum of the previous two terms, like 0, 1, 1, 2, 3, 5, and so on. In the recursive Fibonacci function, if n is 0, it will return 0. If n is 1, it will return 1. Otherwise, it returns fib n minus 1 plus fib n minus 2. This method is straightforward but becomes more slow because it recalculates many values multiple times. The iterative method is more optimized. We start with two initial values, previous is equal to 0 and current is equal to 1. Using a loop, we keep updating them to generate the next numbers. This approach is much faster and avoids redundant calculations. So overall, this slide highlights how recursive and iterative thinking affect performance, even when solving same problems. Thank you.
My name is Rajan and my registration number is AP241100111202. So for the next two slides, I will be explaining the time and space complexity analysis. So let's first go for the factorial function, and in recursive factorial, we see that we'll get the recurrence relation as t of n is equals to t of n minus 1 plus big O of 1. So here in factorial, the function is calling itself again and again, approximately n times, and big O of 1 is coming from the base case. So the time complexity will be big O of n, and the space complexity will be big O of n, because it is using the call stack, and it is approximately n times. Now comes the iterative factorial. So the loop is coming from 1 to n times, nearly n times. So the time complexity will be again big O of n, and there is no such call stack is being used in this iterative factorial. So the space complexity will be simply linear space complexity. That is the big of O. Next slide. So now comes the time and space complexity of Fibonacci series. So for recursive Fibonacci, we know to calculate the Fibonacci for n, we first calculate the n minus 1 and plus the n minus 2. So from here, the recurrence relation will be T of n is equals to T of n minus 1 plus T of n minus 2. And again, due to the base case, plus big O of n. So while solving this recurrence relation, we will get the time complexity is 2 to the power n. That is the exponential time complexity, and it is the worst. It is the worst case. And again, the space complexity will be simply big O of n, because again it is using the call stack. And for iterative Fibonacci, the loop is running. So the time complexity will be n, and there is no extra space being used. So space complexity will be simply big O of 1. So in conclusion, we can say for factorial, it is taking the same time, the iterative approach and the recursive, but there is a difference in the space complexity, because in recursive, it is using the call stack. Recursion is much slower than the iteration. So this is all from.
So hello everyone, my name is Pratham and my API ID is AP241100112441, and I will be explaining the sample results and graph of recursion versus iteration. As you can see the table here, this is n number of times, like here 10, 20, 30, 35 and 40. Here recursively times in microseconds, also iterative time also in microseconds. In the 10 to 25 to 40, 1 to 3 times it will go. For small values of n, both techniques perform fast, but as n becomes large, the difference becomes very clear, as you can see here. Recursive Fibonacci increases exponentially, it becomes very slow. Iterative Fibonacci increases linearly. It remains fast and practical, even for larger values of n. Another observation is the recursion consumes more stack memory, while the iterative version uses very little memory. So from the results, we can conclude that iteration is much more efficient for larger input sizes. Moving on the next slides. Here we discuss the trade-offs, real-time use cases of recursion and iteration in C. Recursion has advantages like cleaner and closest to mathematical formulas, easier for tree traversal, graph traversal, backtracking, and divide and conquer algos. But it has drawbacks, extra function call overhead, more stack uses, which can cause stack overflow for larger inputs. Iteration has constant memory usage using loops, faster in practice because it avoids function call overhead, better for larger inputs, and perform critical systems. In real world application, embedded system and IoT, where memory is small, iteration is preferred. High performance servers, real-time systems, iteration ensures predictable execution time. With this, my explanation end.
Hello everyone, my name is Kritik. My registration number is AP241100111086. So now that everyone in our group has explained their parts, I will conclude this presentation. In this project, we implemented both recursive and iterative approaches for the factorial and Fibonacci using the C language. through these implementations, we compare their performance in terms of time and space. For factorial, both methods take big O of n time, but the iterative version is more memory efficient because it's uses constant space, while recursion uses extra stack frames. For Fibonacci, the difference is even bigger. The naive recursive method grows exponentially with but the iterative works in linear time and uses very little memory, making it clearly the better choice. From these observations, we derived a simple rule. Recursion is useful when clarity and natural flow matter. But when performance and memory are important, especially in C, iteration is the most efficient and reliable option. This completes our presentation. Thank you.